Our journey begins at the heart of our solar system, the Sun. A star of unimaginable power, its fiery breath washes over its inner family of worlds. We leave its searing embrace behind, our ship of the imagination set on a course for the outer darkness. First, we pass Mercury, a scorched and cratered rock hugging its parent star. Then Venus, shrouded in a toxic, crushing atmosphere of carbon dioxide and sulfuric acid rain. We glide past our own home, Earth, a precious blue marble teeming with life, a singular jewel in the cosmic ocean. Beyond our world lies Mars, the red planet, a cold desert world with polar ice caps and the lingering ghosts of ancient rivers. The first great divide we cross is the asteroid belt, a vast, scattered collection of rock and metal, the rubble left over from the solar system's formation. These are the building blocks of planets that never were. On the other side, a new kingdom begins, the realm of the giants. We first encounter Jupiter, a colossal ball of gas so immense that all other planets could fit inside it. Its great red spot, a storm larger than our entire planet, rages on as it has for centuries. Our voyage continues outward, past the glorious rings of Saturn. We press on, deeper into the cold and the dark. We pass Uranus, the ice giant tilted on its side, rolling through its orbit in a strange and lonely dance. As we draw closer, Neptune's true character begins to reveal itself. Its color is a stunning, deep azure, a blue so profound it seems to pull you in. This isn't the color of oceans like on Earth. This is the color of its atmosphere. Sunlight, faint as it is out here, penetrates the upper layers. The methane gas present in Neptune's atmosphere absorbs the red and infrared wavelengths of this light, while reflecting the blue wavelengths back into space. This simple act of physics paints an entire world with a single breathtaking hue. It is an artist's palette of cosmic proportions, creating a masterpiece against the infinite black canvas of the cosmos. But this serene blue exterior is a mask. It hides a world of incredible turmoil. We can see wispy white clouds scudding across the upper atmosphere. They are crystals of frozen methane, like cirrus clouds on Earth, but born of a much colder chemistry. They race across the planet at incredible speeds, stretched into long, delicate filaments by the ferocious winds below. A weather system driven by an internal heat source we are only beginning to understand. There is a furnace deep within its core, a source of internal heat that drives this incredible weather. A place of serene beauty and unimaginable violence, all wrapped in a blanket of the deepest, most hypnotic blue. The beauty of Neptune's clouds belies the true violence of its atmosphere. We are looking at the fastest winds in the entire solar system. On Earth, the most powerful hurricanes might reach speeds of 300 kilometers per hour. Here on Neptune, the winds are supersonic. They can scream across the planet at more than 2,000 kilometers per hour. That is faster than the speed of sound. These winds push the white methane clouds across the planet's face, creating the streaky patterns we observe. What could possibly drive winds of such incredible velocity on a world so far from the sun's energy? The answer, again, lies deep within. Neptune's internal heat source convects outward, remnant warmth from its formation billions of years ago. Combined with the planet's rapid rotation, a day on Neptune is only about 16 hours. This creates a powerful Coriolis effect. Rising internal heat and swift rotation together whip the atmosphere into a frenzy, generating record-breaking supersonic winds. Beyond its atmosphere, Neptune holds another profound secret, its magnetic field. It is wildly tilted. On Neptune, the magnetic axis is tilted by a staggering 47 degrees. The magnetic field is also significantly offset from the planet's physical center. As Neptune rotates every 16 hours, its tilted and offset magnetic field wobbles and tumbles in a chaotic pattern. For centuries, Saturn was thought to be the only planet with rings. But we now know that all the gas and ice giants wear rings. As we orbit Neptune, we can see its own rings, very different from Saturn. Neptune's rings are faint, dark, and tenuous. Ghostly, hard to see from Earth. They were only confirmed when a spacecraft flew past. Not icy and bright, but dark material, possibly radiation-altered organics, very low reflectivity. Several distinct narrow rings make up the system. Gall-Leverrier atoms. These rings are clumpy and incomplete, not broad sheets like Saturn. The Adam's ring contains bright, concentrated arcs. Liberté, égalité, fraternité. For years, it was a mystery why those arcs didn't smear out. The answer is a subtle gravitational dance with a tiny moon. Galatea orbits just inside the Adam's ring. Its gravity shepherds and corrals dust and debris into arcs, a stable resonance keeping particles from dispersing. Neptune may be the ruler of its domain, but its most fascinating subject is its largest moon, Triton. As we approach, we see a world unlike any other. It is a cantaloupe-textured sphere of pinkish-hued nitrogen ice. Triton is enormous, larger than the dwarf planet Pluto. But what makes it truly unique is its orbit. It circles Neptune backwards. Triton's retrograde orbit is a smoking gun, undeniable evidence that it did not form with Neptune. It is a captured wanderer from the Kuiper Belt. The surface is a chaotic jumble of terrains. Smooth volcanic plains, ridged networks, crumpled mountainous regions. It is one of the youngest surfaces in the solar system, constantly being repaved by geologic activity. Despite its surface temperature of a mind-numbing -235 degrees Celsius, Triton is geologically active. These are cryovolcanoes, plumes of vapor and dark dust erupting from beneath the ice. Sunlight, even as faint as it is, penetrates translucent nitrogen ice, warming darker layers beneath and vaporizing nitrogen. Pressure builds until it erupts in plumes carrying dark, dusty material miles into the sky, caught by a tenuous nitrogen atmosphere and sheared into streaks across the polar cap. A dynamic canvas painted by dark nitrogen-powered geysers. For nearly all of human history, Neptune was invisible, then just a mere point of light. A fuzzy, indistinct disk in our most powerful telescopes. Its true nature remained a complete mystery, until Voyager 2. All of the incredible details we've witnessed were revealed in one breathtaking flash, starting with Voyager 2's approach, the Great Dark Spot, those supersonic winds, the ghostly rings, and even the cryovolcanoes of Triton. This revelation came from a single intrepid explorer, Voyager 2. Launched in 1977, set on a grand tour, Jupiter, Saturn, Uranus, and finally toward Neptune. After 12 long years of traveling, Voyager 2 reached Neptune in August of 1989. It was humanity's first, and so far only, close-up encounter with this distant world. The data it sent back across billions of kilometers transformed our understanding overnight. The encounter was a triumph of engineering and curiosity. The scale of Neptune's orbit is, honestly, pretty difficult to comprehend. It orbits the Sun at an average distance of about 4.5 billion kilometers. That's 30 times farther from the Sun than Earth is. Light takes more than 4 hours to travel from the Sun to Neptune. A radio signal from Voyager 2 took 4 hours and 6 minutes to reach Earth. This immense distance defines every aspect of Neptune's existence: coldness and dim daylight. Because of this vast distance, Neptune moves very slowly in its journey around the Sun. While Earth completes its orbit in 1 year, Neptune takes nearly 165 Earth years to make a single circuit. Since its discovery in 1846, Neptune has completed just one full orbit. In 2011, it returned roughly to the same point in the sky. An entire human lifetime is not even half of a single Neptunian year. The seasons on Neptune, driven by a slight axial tilt similar to Earth's, each last for more than 40 Earth years. The sunlight here is 900 times fainter than it is on Earth. If you were in Neptune's upper atmosphere, the sun would look like an intensely brilliant star, not a disk you could resolve. Without its internal heat source, Neptune's atmosphere would be far more placid, lacking the energy to drive colossal supersonic storms. Neptune does not actually mark the end of the solar system. Instead, it marks a beginning. It is the gatekeeper to a vast, new realm, the Kuiper Belt, a colossal, donut-shaped region of frozen remnants. Icy worlds of rock and frozen methane, ammonia, and nitrogen, pristine remnants of planet formation. Hundreds of thousands of objects larger than 100 kilometers, and likely trillions smaller. Neptune's immense gravity sculpts the belt, shaping countless orbits and locking many in resonance. Pluto is the best-known example. For every 3 times Neptune orbits, Pluto orbits twice. Many objects share resonant paths. Plutinos and other TNOs shepherded by Neptune. Dwarf worlds like Eris, Makemake, and Haumea lie beyond, diverse and mysterious. A gravitational nudge or a collision can send an icy messenger inward, the source of many comets. As it falls inward, the sun vaporizes its ices, and a magnificent tail forms, connecting darkness with light. Neptune acts as gatekeeper, occasionally sending icy messengers to us. Our journey is coming to an end. We pull back from Neptune, the great blue world shrinking once more into a brilliant point of light. We see it hanging against the star-dusted velvet of the Milky Way, a solitary beacon in the profound darkness. The study of Neptune and its sibling Uranus is crucial for understanding planets beyond our own. In our galaxy, ice giants and sub-Neptunes are common, worlds between Earth and Neptune that challenge our theories. By understanding atmosphere and dynamics of our ice giants, we gain a reference point to interpret distant worlds. Its mysteries remain. Why is its internal heat so much stronger than Uranus? What created its tilted magnetic field? What secrets lie beneath Triton? We have had only one brief glimpse. Our knowledge is based on a few hours of data collected decades ago. To truly understand this world, we must go back, orbit for years, map storms, probe the interior, maybe land on Triton. Future missions could map storms, probe interiors, and witness nitrogen geysers up close. For now, Neptune waits. The distant blue giant continues its long, silent journey through the darkness. A world of supersonic winds and ghostly rings, guarding a realm of icy relics.